Hello everybody and welcome to another math video. In this video I will be going over notes for matrix applications, aka assignment number 6 in the ABS course. And in this video we will be talking about adding, subtracting, multiplying matrices by scalars, as well as multiplying matrices. So this directly builds upon what was gone over in notes for assignment 5. So let's jump right into it. The first example here, we have some directions. It says write your answer in matrix form and label the rows and columns. Okay, so Miss Smith and Mr. Jones sell cars for an agency that sell only 2 models. Use the matrices below that show the gross dollar sales for 2 months to answer questions that follow. So here we have August sales. We know Miss Smith sold $54,000 in compact cars and $88,000 in luxury cars. And Mr. Jones sold $126,000 in compact cars, $0 in luxury cars. And we're going to call this matrix A. And then we have something very similar over here for September sales. And you might be wondering, hey, why are the September sales so much higher than the August sales? Well, out there in the real world, in September, generally in September is when the new model year's vehicle is released. So you can see Miss Smith sold a heck of a lot more compact and luxury cars in September, and so did Mr. Jones. All right, so we have questions here. What were the combined sales in August and September for each per salesperson in each model? Well, it's pretty simple. When we're trying to figure out combined sales for both months, we know this matrix represents August and this matrix represents September. So we can just copy these numbers down into our matrices here and then add them up element by element. So here I have the elements, each matrix here, and then we just add these up element by element. So we can say it would, in the upper left, or for Miss Jones compact cars, we can add 54,000 and 228,000 to get $282,000. And we can do the same thing for the sales amount of Mr. Jones in August and September for compact cars, and Mrs. Smith's luxury car sales from August and September, and Mr. Jones' luxury sales in August and September. And then we would have the total for each of these. So we would just have to add these two together. Let's see here. These two together, these two together, and these two together to get the totals over here like this. There it is. So we just have to add. All right, let's see. The increase. So for part B, it's down here at the bottom of your screen right now. I'll move it up in a second. What was the increase in sales from August to September? What do you think that would look like? Well, increase from August. So I think if we did something like this, we know that Miss Smith sold $54,000 in compact cars in August, and then it jumped way up to $228,000 worth of sales in compact cars in September. If we wanted to figure out how much it jumped, we can just take the September amount and subtract the August amount. But we would have to do that for all of these, so we would be taking all of the amounts of matrix B and subtracting the amounts from matrix A. So let's see if that's right. Move this up and check that out. B minus A. Look at that. So all I have to do is substitute all of these values here and substitute all these values here and do an element by element subtraction to get this. So as you can see, we have matrix B here, matrix A here. We did element by element subtractions, and we got this answer here. And this matrix can be interpreted because the first column is always the compact cars, the second column is always the luxury sale dollars, I guess. The top row is how well Miss Smith sold cars, and the bottom row is how well Mr. Jones sold cars. So for example, this one here, this element, $322,000 is the increase in sales for Mr. Jones luxury sales from September to August. And we can interpret these the same way. All right, what is next? So we have, finally here, part C, says both salespeople receive 5% commission on gross sales. So we want to compute the commission for each person for each model sold in September. So what this means is that we want to take 5% times the entire matrix. This is what we call scalar multiplication. We're just multiplying every element in the matrix by some factor. So once again, with the percents to decimals, percentages rarely, almost if ever, play well when in math. So we need to be aware that we need to change the percent into a decimal here. So I substitute all of these September sales in here, and then I will distribute, more or less, I call it a super distribution. I will multiply all of these numbers by 0.05 to get the following matrix. And this matrix here represents the amount for each, the amount commission they earned for each type of car they sold. And then we can even take this a step further. If you take a look, just for Mrs. Smith here, or Miss Smith, if we add these together, we can calculate the total amount of commission she earned for the entire month, and the same thing for Mr. Jones. Or we can add these together and figure out the total number of commission made from compact cars, or we can add these together and find out the total commission made for luxury cars between Miss Smith and Mr. Jones. All right, on to the next example here. We have example 2. This says, a company with different plants manufactures guitars and banjos. Its production costs for each instrument are given in the following matrices. So here we have materials costs for guitar and banjo in plant A, and labor costs for guitar and banjo in plant A. And we have something very similar over here for a different plant, plant B. So we have this question here. If both labor and materials costs at plant A are increased by 20%, find the final prices of these items. So this is slightly different. It's going to use the idea from 1C in the previous slide, where we need to multiply the entire matrix here by 20%, or 0.2. But that's not going to give us the final answer. So let's just go ahead and do that first and talk about what the final answer will be here in a few seconds. So here's what that matrix looks like as we multiply all of the values from plant A by 0.2, which again represents the 20% that we were given here, 0.2, or if you like 0.20. So what's happening here? This is the increase on these prices. So what we would need to do then is go back and add this matrix and this matrix together, right? This is just the increase. This is not the total. So what we can do is we can add these element by element. So like this one and this one, this one, and this one, just like we did in the previous slide there. And we can get the total cost of the items in a new matrix. It'll look something like this. There you go. But even from there, we know that the top row is how much the materials cost after the increase, and the bottom row is how much the labor costs after the increase. But the question is asking, find the final prices of the items. That's what we're looking for. So you'll see back here, the first column here is the total cost of the banjo, or the total price, of the guitar, not the banjo. The second column would be the total price of the banjo. And after the increase, we would still have to add the columns together to get the total price of each. So the total price for a guitar would be $164.40 after you add those together. And the total price for a banjo would be $196.80. So these are what we're looking for. And these two values answer the final prices of the items. So we can do something very similarly to this one here, this part B. If both labor and materials at plant B are reduced by 15%, that word is super important, reduced by 15%, find the final prices of the items. So I'm going to do something very similar. We can multiply the matrix B by 0.15, and we can get a new matrix. And when you do that, you can see the amounts that are original materials and labor costs are decreased by. So this is how much we will take away from these amounts here. And when you do that, so it would be 56 minus 8.4, and that would be the new materials cost for the guitar. And then 42 times 6.3 would be the new materials cost for the banjo. So we're going to subtract B minus this matrix here to get a new matrix that looks like this. Now this represents the new material cost for guitar, new material cost for banjo, the new labor cost for guitar, and a new labor cost for banjo. And again, we're trying to find the final price of each item, being the guitar and the banjo. So if we just add these together, you can see here the first column represents the materials and labor costs for guitar. If we add these together, we can find the price that we should be charging for a guitar. So that would be $119 for the guitar and $133.45 for the banjo. All right, so there's that. Now there is a slightly faster way that we could have done these two exercises, and I'm going to go over that very briefly. Since we are increasing, again, important word there, increasing by 20%, if we just add that 20% as a decimal to 1, 1 represents the original cost of everything over here in this matrix, and the 0.20 represents the additional increase that we would have there. So we add these two together, get 1.2. And if you just go through and multiply everything in matrix A by 1.2, you will end up with this matrix automatically without needing to multiply by 0.2 and then adding it to this, right? We would take that 0.2 and add it to the matrix right away. And then we would only need to do one multiplication and we're good to go. Similarly, down here in part B of example 2, this reduced by 15%. Well, 15% is 0.15 as a decimal, and since we're reducing, we would subtract it from 1. You'll notice we're using 1 again. So it doesn't matter if we're increasing or decreasing or upped or reduced, we are always starting with 1 and then either adding or subtracting based on the word we have. And when you subtract these two, you get 0.85, which means that if you had just multiplied the original matrix here by 0.85, you would get all of these numbers here. All right, let's move on to example 3, and the final example for this video. Example 3 states, in a local Texas election, a public relations firm promoted its candidates in 3 ways: telephone calls, TC, house calls, HC, and letters. The cost per contact is given in the matrix M, and the number of contacts of each type made in 2 cities is given in matrix N. So here are the costs for each type of communication, and here are the number of communications that went out for each of 2 different cities in Houston and Austin. So the first 2 parts here are not even, we don't have to worry about combining these matrices in any meaningful way. All it's asking you to do is find the total number of telephone calls that the public relations made. And so TC, or telephone calls, we can just add these together. 1,000 and 2,000 more is 3,000 calls. Find the total number of contacts for both cities. Well, I just mentioned that this row represents Houston and the bottom row represents Austin. So the number of contacts would just be the number of telephone calls, house calls, and letters that were put out for both cities. So if we just add these rows across, then we can have the total number of communications. For Houston, that would be 6,500 contacts, and for Austin, that would be 10,800 contacts. And I'll take a second here to say that units are important. So I didn't just answer 3,000 here, I answered 3,000 calls. And down here, I didn't just answer 6,500 or 10,800, I used the word contacts after that. Just as a general thing in the real world, using units are important. So part C, it says if either product, m times n or n times m, has a meaningful interpretation, find the product and label its rows and columns. So what we are looking at is, can you multiply m times n? Now, if you go back and look at the dimensions for each of these matrices, this is a 3 by 1, and this is a 2 by 3. And if you'll recall, when we multiply 2 matrices together, the inner dimensions have to match. So if you have m times n like this, we can write the dimensions underneath, 3 by 1 and 2 by 3, and these inner dimensions do not match, so we cannot multiply the matrices in this fashion. However, if we write down n times m, we know this is a 2 by 3 and this is a 3 by 1. These match, so we can multiply them as long as they're in this order. N times n. So here are the matrices set up in this particular fashion. We have n times n. And what we do is we will take the first row of this matrix and multiply each element by the first column of this matrix. So the 1,000 would be multiplied by 1.2, the 500 would be multiplied to 3, and the 5,000 would be multiplied to 1.45. So I'm going to do that, and once you multiply all of those elements together, then you'll add those 3 results, and you'll get this. So I realized I went ahead and did more work. When I was talking about multiplying the first row element-wise by the first column, you'll get 9,950, And when you go back and multiply this second row by this column, you'll get 16,400. Now, a couple review ideas here. This is a 2 by 3, and this is a 3 by 1. So the inner dimensions tell you how, whether or not you can multiply these matrices together, but the outer dimensions, the 2 and the 1, they will tell you the dimensions of your answer. But not only that, they will tell you what these numbers mean. They will tell you the cost, because that is what this column was describing, was the cost. And we know that this, the top row for this matrix was Houston, as you can see here, and the bottom row for this matrix is Austin, which you can see here. So the rows of the first matrix will match up with the rows of your answer, and the column of the second matrix will match up with the column for your answer. So here we have Houston, and here we have Austin. So what do these numbers mean? Well, the election, the public relations firm spent, the firm spent $9,950 in Houston and $16,400 in Austin. Like, that's what these numbers mean. And that concludes the notes for assignment 6. I hope you understood this. Good luck.